Right, in lesson 29, a second topic that we have is called zero exponents. And we've already talked about what we have when we have negative exponents. So one rule that we've previously discussed that any number to a negative exponent, we can't simplify it or find its value as it is. So in other words, in the form that it's written right now, this negative value, this negative power is in the top, and what we said is we can force the negative exponent to become positive by moving it down or downstairs. So in other words, when we move this whole thing down, it's forcing the negative exponent to become positive, and what's left in the top is 1. Now we easily can see that 2 cubed meaning 2 times 2 times 2 is 8. So our value for this is 1/8. Now with the other part of this lesson then is when we have something raised to the 0 power. Now when something's raised to the 0 power, really it's a pretty easy rule to remember, because anything to the 0 power, and I'm going to erase this here first to get a little bit more room, anything to the 0 power is simply 1. So in other words, 2 to the 0 is 1. 10 to the 0 is 1. So anything to the 0 power is 1. Now I want to go into just briefly a little detail on why it's 1. So say for example we're taking the 2 to the 0 and say we're trying to reason out why that is 1. Alright, let's so if I have 2 to the first, say 2 squared, 2 cubed, okay, let's evaluate these values. So this would be 2, and I'm going to put 2 to the 0 right at top. So 2 to the first is just 2. 2 squared is 4. 2 cubed is 8. Now if you look at the pattern here, they're multiplying each number. They multiplied 2 by 2 to get 4. They multiplied 4 by 2 to get 8. So they're multiplying everything by 2. Now what number could I multiply by 2 to get 2? Well, it has to be 1. So anything to the 0 power is 1. Let's take a look at the first example. Now in this example, well, that's easy. Anything to the 0 power is simply 1. Now this looks like the same type of example as example 2, but notice we have the negative sign in front. Now here's something that you really got to pay close attention to. If I have the opposite of 8 to the 0 power compared to a negative 8 in parentheses to the 0 power. Now which of these two examples is the negative 8 being taken to the 0 power? Well, it's this one, because it's in parentheses, and we know that that whole value, any value being taken to the 0 power is 1. Now here in the top example that I have, just 8's being taken to the 0 power. So just the 8's being taken to the 0 power. So this part, I know that 8 to the 0 power is 1, but then I got to take the opposite of that. Take the opposite of 1. So in this particular example, it's a negative 1. Alright, in example 3, what's being taken to the 0 power? Is 3 being taken to the 0 power and then take the opposite of it? Or is a negative 3 being taken to the 0 power? And the answer you should have had is, since this is in parentheses, the negative 3 is being taken to the 0 power. That whole value is being taken to the 0 power, so it's 1. Now if I had the opposite of 3 to the 0 power, I would take 3 to the 0 power, which is 1, then take the opposite of 1, and in this case I'd get a negative 1. Now, this looks a little complicated, but really it's not. What's being taken to the 0 power? Is p being taken to the 0 and m and k squared? What's being taken to the 0 power? Well, the answer to that is this whole thing, this whole value, whatever value this is. So in other words, if we knew what p was, m was, and k was, and squared it, I'm going to get one value. And I take that one value. You know, maybe it's 5, I don't know. Maybe it's 10. But if it was 5, what's 5 to the 0? So in other words, what's 5 to the 0? Or if the value of that came out of this is 10, what's 10 to the 0? Well, since this whole thing is being taken to the 0 power, answer is 1. All right, now we're going to shift gears a little bit. Now in example 5, we're multiplying powers. So in other words, the only operation going on in this whole problem is multiplication. And remember, I'm not going to write this out, but from previous problems, you know that this means the x to the negative 3 times the y to the negative 8, with each of these being separate. All right? So when you multiply powers, you add the exponents. And remember, that's a z to the first. So let's take our x's, let's take our y's, and let's take our z's. Now the only difference with this lesson is you've got some negative exponents involved. So let's do the x's. And I'm going to change colors here. What is a negative 3 plus 4? So when you multiply powers, you add the exponents. So 3 degrees below 0 goes up 4, that's 1. Plus 2 more is 3. Now how about the y's? Negative 8 plus 5. So in other words, 8 degrees below 0 goes up 5. We're still cold. It's still in the negative temperature. So negative 8 plus 5 is a negative 3. And looks like that's all for y, so a negative 3. Now how about the z's? I have 1 plus 5, 6. Now, depending on what they ask you to do, and I mentioned this in the previous video, how about if they wanted you to write the final answer with all positive exponents? Now, here the 3 is positive. Here the 6 is positive, so I don't have to worry about those. But this one is negative. So what I have to do here is I'm going to leave the x cubed times the z to the 6 up above, but I'm going to force this power to become positive, so I'm going to drop it down. I'm going to move that down, and it's going to become y to the positive 3 power. Now I've written it with all positive exponents. So this answer is acceptable, but so is this answer. It depends on what they ask you to do. All right, in example 6, same type of problem. How many x's, how many y's do I have? Now let's multiply the powers by adding the exponents. So let's do the x's. What's 6 plus 2? Well, that's 8. Now let's take the y's. Something interesting happens here. What's a negative 3 plus 3? 0. But we can simplify this a little further, right? Because we know what y to the 0 power is. We know that anything to the 0 power is simply 1. Now, I really want to emphasize one point. So if this is 1, what's x to the 8th times 1? Anything times 1 is itself. So it's x to the 8th. So we really don't have that value of y involved because the value of y to the 0 becomes 1. And anything times 1 is itself. Right, final problem that I have, and that's the distributive property. Now, I'd like you to simplify this by using the distributive property. So we're going to take what's outside times that, and finally times that. So I have 2x to the negative 2 y cubed times x squared y to the first, I'll write it, minus, and then the 2x to the negative 2 y cubed times 3x to the negative 1 y to the negative 3. Right now, the first thing I need to do is do my multiplication. All right, so in this one right here, okay, the big number, the 2, is first. Now let's multiply our powers. So let's do the x's and let's do the y's. The x's, what's a negative 2 plus 2? 0. Let's do the y's. What's 3 plus 1? 4. Minus. Now, again, remember this is all multiplication. What's 2 times 3? 6. And now let's see how many x's and how many y's I have. How about for the x's? A negative 2 plus a negative 1. So temperature drops 2, drops 1 more, negative 3. How about the y's? 3 plus a negative 3? 0. Now, as some of you might have already been thinking, we can simplify the x to the 0 and the y to the 0. We can simplify those. Alright, so I'm going to make this a different color so it's a little easier to see. So x to the 0 is simply 1. Alright, so I have 2 times 1 times y to the 4th minus y to the 0 here is 1. So I have 6 times x to the negative 3 times 1. Alright, so here in the first part, 2 times 1 is 2, and what's 2 times y to the 4th? 2 to y to the 4th. Minus, and then over on the right part, I simply have 6 x to the negative 3. And that can be our final answer. Now, remember if they wanted all positive exponents, you would simply drop this part of it down. And I'm going to switch colors. Might be a little hard to see, but I would have 2y to the 4th minus 6, leave the 6 in top, drop the x to the negative 3 down, becoming x cubed. And this would be written with all positive exponents. So, the purpose of this lesson was how to evaluate or simplify zero exponents when a power has an exponent of 0.